every year with Endeavor, we do a 5-month course, and in that course, with the students, we build a project, which is typically a house or something like a Camp Corsa building. For the first time with Endeavor, we decided to take on a renovation, which I think is really interesting. However, visually, experientially, it actually doesn't seem that way, and you'll see with the photos. But there's as many renovated house starts as there are new building starts in Canada right now and in the States. And I don't know if anyone ever looks at those numbers when we're talking about healthy homes and healthy materials and how we want to implement that. But I think in the States it's 1 million new home starts, and in Canada it's about 250,000. So the renovating starts are actually the same amount, or a bit more. So you're looking at a few million homes in North America that are getting built right now. So no matter what we do and talk about here, those homes are happening. So I think it's important that we address that, especially in a renovated context as well. And so here's the beautiful, not beautiful project. So you can imagine you just flew here from Ghana or the Netherlands, like some of our students, and we bring them to this job site, and we're going to be like, this is what we're working on. And they were like, okay. And for those that know Endeavor, know Chris Magwood and the history of the projects, to come and see this, it was like this was the first day, and it wasn't impressive. And I was excited. I was super pumped about this, because for us building nerds, and for those in the room that get really technical, as an educational project, this is a perfect blank rectangle canvas. I'm like, this is the coolest thing. We can test out materials. We can talk about them. It's not too big. For the students, they were like, where's this like giant, straw bale, round roof, shingle building that we can get into? So this is first day, and I'm trying to explain like a calendar here, the schedule of the project, and they're like, what have we got ourselves into? And then further to that, this is their, like semi-nervous smiles. You can see Justin up there. He's like, dude, I just came from Minnesota. Why am I here? You can see me with my eyes closed, looking kind of pensive, and that's me wondering what I got everyone into for the summer. And this is also kind of showcasing the inside of the building, and I'll talk a little bit about the history of the building. So it is over 100 years old. It was just a concrete block garage space that was made to work on cars and to tinker, like that's what the old family had it for. And the client had always wanted to turn it into an artist live work studio. She contacted us. She knew about Endeavor. She was really excited to work with natural materials, and of course we always try to engage and get into all of our goals with every project. So right now we always try to work towards zero carbon, zero indoor air quality, zero toxins, and the idea of zero like net energy use. So if you can't offset your energy use, ideally you're building something that doesn't need a lot of energy. So the client was into that, so we were like, okay, let's apply that to this. A couple of things to note in here: that drum that says fuel and oil had kerosene in it, and there was some car oil that we found in the ground as well, which relates to this healthy home aspect. In a renovation context, you have a front-end inherent loaded indoor air quality problem when you start. And that doesn't just affect you, it can affect the client inside the home. If you're not taking care of how you're removing the materials, you could be transferring that into the house of the existing, or to the client of the existing home, and also the environment as you're taking stuff out. So there's a whole other layer to indoor air quality when you're dealing with the renovation. I'm presenting this today as a very loose case study. This isn't going through any deep scientific rigor, so don't judge on that part. Initially, for any project, you kind of want to identify the main causes of poor indoor air quality, identify the strategy materials to combat the causes, implement, and then something that I've enjoyed about a few of the presentations over the weekend is kind of an objective review of what the findings that people are coming to. You know, because you can't hit a home run on every project. I know we want to, but it's probably not going to happen. And again, the 2 million homes that are being built are going to happen whether they have zero toxins or not. So I think the review process is really good because you look at the project objectively at the end and what you can fix. In Canada, we spend about 90% of our time indoors, which is a reason and a concern to take care of your indoor air quality. The pollutants indoors is often 2 to 5 times higher than they are outdoors. So those two factors alone is a high contributor. And with the influx of new building, the indoor air quality is getting worse and worse as we decide to create the plastic bag and tighten that up while also introducing more synthetic materials. We're making it worse. So it's starting to be addressed, you know, starting at this level. Some quick points here about the sources that they come in. So combustion sources are gonna contribute, natural in origin, radon, mold, pets, and then building materials. There's actually a whole other source in here that we can't control, and that's your furnishing, which is completely out of our scope of work. But we can build a home with zero toxins, and a client can have all this furnishing that could have flame retardants on it, and that could probably be worse than the bad insulation you used, which is behind your barrier. The couch could be potentially killing you. So this is a bit of a joke here, but it's kind of true and sad and I think all the builders here go through this. So our strategy is to, you know, re-research everything we've already researched, and then we do more researching, and then we discuss the research, and then we discuss the research again. Like that, I mean, I don't know, I feel like Glenn probably knows, a few people here know, like as a builder in this industry, this is like you're just kind of researching nonstop, and Chris touched on that today, like addressing the paints. It was 4 hours of research for one understanding one composition of paints and whether he's going to use that or not. So in the discussion part is, you can imagine, like I work for Endeavor and Chris is my boss, so when I'm identifying a product to be used, I'm talking to Chris about it, and he's like, did you read this? Did you read that? What do you think about it? Like, so this kind of never ends, and it's kind of a ridiculous strategy, but it's what you do. I've looked at the same MSDS sheet for one material probably like 6 or 7 times. A couple points with the MSDS is everyone actually should know how to read it. That's like by law, like all managers are supposed to have one on site with all the materials you're using. You should have the accompanying MSDS sheet in a binder, which I don't think many people do. Bigger commercial stuff, for sure. But the other funny thing is the sheets are never written in the same way or in the same order. So even that list and how like Chris was presenting it, it seems pretty fluid. It's not. Like some sheets are a complete jumble, and you're like, where did the whole carcinogenic table go? Like you can't even find it. So we found out that the building had no foundation, which I kind of knew. You know, had your fingers crossed, and then so we needed to address it with some shallow frost protection, and you know, in terms of healthy materials, you don't have many options. So we ended up using rock salt to cover that, which again, like this is where I look at this objectively as this is a review portion. You can discuss using carpet if that's something you really care about in terms of an environmental recycled impact. A lot of people use foam in this application. So again, this doesn't seem very exciting, but to the technical builder, like you think about this stuff for a few days on what you want to do with it. So the idea here was to stop A, water from getting under the building, and B, stop, if for any water that gets under the building, it's not going to freeze. Not exciting stuff, but you know, it's a part of the goals. Moving back one slide, this is the interior space as it's starting to get cleaned up. A couple things to note here is we're able to salvage a few of the materials, which I thought was super exciting. The main beam that's in the middle supporting the roof, once we started to dig into the project, we found was very, very old growth Douglas fir. And for any nerdy craftsperson in Ontario, when you find old growth Douglas fir on your project, you're like, oh, cool, that's great. So we were able to save that material and reuse it, and you'll see that in the later slides. So here's just another fun research thing that we did. So this is like a low embodied carbon concrete. I guess Chris and Tim have been coining it a Roman concrete. Here's a classroom day that we have with Endeavor where we test out these materials and we go through the whiteboard, and you can see, you know, our trade secrets here on how we make that mix. So you got your typical concrete mix above, and how we just replace the Portland cement with lime and metakaolin and a sand and gravel mix, which is essentially a gravel. All of the load-bearing posts in the building were bearing on this concrete. So another really cool research thing that we did here was we developed and implemented an insulative plaster. So in the renovating world, one of the best practices that's being advocated is to on a masonry wall. So if you have like a double brick home and you want to insulate it, one of the first things you should do to the inside of the brick is actually put a plaster render over the whole thing to make it smooth, and you want to get rid of any convective loops that you would insulate against. It also helped with creating an air barrier. We took that and wanted to replace the Portland content and then actually come up with a potential insulative material. So this picture is showing how we are tying in an air barrier into that system, but it's also showing the concrete block wall bare because that whole wall got covered in this insulative plaster, which then became our air barrier but was also vapor permeable. Another cool technique we employed with our air barrier was we took it and put it to the top of the roof. So you can see the existing roof in here. We turned that into a finished ceiling, and we brought the air barrier around the block wall and up onto the roof. And then we built a roof on the existing roof. And so that's what this is showing. And the way we were able to do that is the existing roof actually wasn't tied into the concrete block wall at all. So we actually just jacked it up and just slipped this thing under and brought it over. Which, I mean, we had a blast doing. We had a student from the Netherlands that actually worked for Zender, which they supply ERVs, and he was really into the barrier detailing. So he. Did you anchor the roof down after you got that thing slipped through? Oh yeah, that was exciting. Well, I mean, again, in the nerdy world, when you're on the site, you think it's ingenious, but we needed to make a plaster stop for the insulative plaster, and so we fastened that to the wall, and then we were able to. So this is, you know, having to bring that air barrier up the side of the concrete block as well, which wasn't very fun. And yeah, we're still on the roof here, and so this is our air barrier on the ceiling / roof. We have some Mento just at the end and against the block wall. We're just playing with the idea of not allowing any of the moisture from the block wall to come into the assembly. Like thinking of like the vertical as a rain screen, but yeah, that's Intello across the whole roof. And then this is the roof on top of the roof that we built, which there's economy of scale to this. So trying to fix, when you're dealing with the renovation and you're trying to fix the existing building to work with high performance and to be straight and flat, it can actually be really hard to do and take a lot of time. So instead, you just leave what's there and then you build new, which is, when you build new, it's really fast and efficient. So we built a roof on the roof. So here we're getting into the insulative plaster. This is just showing some of the detailing that you have to do to make that a fully sealed air barrier. So you have to make connections into your window as well. So what's really interesting is the European companies that provide air sealing material, they have air sealing tapes that work with plasters. So this is a felt tape, so it's taped in one portion, the rest of it's loose, so that you can actually plaster into that, and that will make your connection as a full air barrier. And so here we are testing out the insulative plasters. So kind of the main product is Pour-Aver, which I know some people have learned about because I know Chris has spoken about it, but for those that don't know, it's just recycled glass. And the way, the composition of these very, very small glass beads is that they have little holes in them, and that's able to slow down the transfer of heat and cold air. When doing the mixture, we were just taking that Pour-Aver and mixing it with a whole, not a whole bunch, but a few different ingredients at different ratios to see if we could come up with something that was workable and something that was effective. And one of the first things we used was a little bit of gypsum to help as a drying agent, and it was actually drying too quickly. So we ended up just using Pour-Aver and lime and a little bit of water, and that was it. And we were able to, get a continuous R2 air barrier on all of our concrete block wall. It was really cool. And again, review, case study, transparency, it's a monolithic thing, so it does crack. So we then had to we would have to mesh the cracks and go over them again. Yeah, and for those that have plastered before, it was really, really fun and easy to plaster. Like if you've worked with earthen plasters or lime plasters, doing the Pour-Aver plaster was, for the students, for a introductory to using plaster trowels, it was great.
Is it light?
Yeah. Yeah. So here's the whole interior space now with the insulative plaster. We did all the concrete block walls in it. The only wall we didn't do was back here, and that's because we took that wall down. Here we are with myself, very excited about taking down this fir beam. Students, didn't fully understand why, but that's what happens. Just some detailing for all the air barrier nerds out there. Always being a step ahead in your assemblies to make sure your air barrier is connected in all places. So here, when we replaced our fir beam with the new beam, making sure you have your barrier design in place before you put the beam up. And here we are taking down that concrete block wall that we're gonna frame up. Another thing here is we started the project on the first day. They were disappointed. They were like, "What are we doing on this project?" And then we couldn't get a building. Well, we didn't have the building permit. There was a wild variance problem going on with the property, so we actually couldn't install this beam right away, which meant we had to come up with work that wasn't structural. And so one of the first things we had to do was dig that trench around the renovation. So that was they're like, "Wow, sweet, natural building." We were like, "Cool, let's dig this trench." And then, and then, in my head, I'm like, "Oh man, there's this concrete slab that's got to come out too, and there's the tar and gravel roof that's got to come off." I'm like, "This is not cool. I'm a bad guy." So I decided to leave the slab in place, which was great because we didn't have to deal with the labor involved, but we also didn't have to just throw all that stuff into the landfill or to be recycled. So that emotion of my sympathy for the students actually allowed us to keep the concrete slab, which worked out really well. And then we actually, the slab was a disaster, so we kind of laid down a layer of limestone screenings, and then we put a pretty heavy vapor radon air barrier along the bottom. The height was a concern. The roof is on a 412 slope, so at the far end where the ceiling was higher, it was a nice height. At the low end, it was about 7 feet, which I kind of got focused on the low end, but then when I was able to be like, well, no one's just going to walk along the one wall the whole time, they're going to live in the whole space, it justified being able to leave it. And so we took down this whole wall on the east side. We had to put a door in there. And then again, another concern and one of our goals is not to have waste. So we kept all the blocks on site, which you can see in the lower corner. And then because our roof went higher, we actually just reused all the blocks to go along the parapet. Here's our team working on the floor. I mean, I guess a fun note there is when you put your post in, it's, you know, if you're going directly on concrete and you're using wood, it's nice to break that up, but also to have a continuous barrier wrapping it underneath your posts. And so we do like pour over at Endeavor. So we poured a R11 5-inch and change monolithic and insulative slab over top of that concrete. And a side note to that is at Endeavor we'll do things that might not always transfer to actual industry. I think pour over has that opportunity. It's, yeah, you put a little bit of lime in there, put a little bit of metakaolin. The lime and the pour over itself the pour over is pretty inert. Nothing's going to affect it. The lime will stabilize, and the metakaolin will bind it. Yeah, we're just using hydrated lime. Yep. Which, again, like if you look at MSDS of lime, it's very caustic.
Yeah, don't eat that stuff.
It is. Don't let it get on your skin. But seriously, like it is so caustic, and not even on an overexposure level. Like, and for some people, depending on your skin, like a little bit of just dust from the air gets on your skin, and it can start to burn, and you might not notice for a day. We like using lime, but you need to understand how to use it for sure. Eyewear, respirator, pretty much a hazmat suit is probably the recommended use. No, but this was middle of the summer, and George isn't wearing full sleeves, but Justin is wearing full sleeves and pants. That was very much a standard. And so this is kind of like our initial insulation and barrier practice to the floor and walls. I know there's been a bit of traction with concrete companies that could potentially just fill up a whole truck with this and drive it to site like a ready mix, because this is used in lightweight concrete. Yeah. So it's already like they already have the contacts. The account's already set up, so you would just be specifying the mix. Yeah, I would definitely implore anyone that's interested in this to and if you don't want to use foam or rock salt as your sub slab, because that's it right now.
Straight up 2 mil diameter pour over with just the Meta-K is about 70 psi, which is that's as strong as an extruded polystyrene, like a mid grade. You add that, if you tamp it when you're putting it.
Yeah,
down,
you have to tamp.
Yeah, you can put a slab on that. Yeah, I don't know if I'd do it in an industrial garage, but in a home, yeah.
And see,
put earth and floor on it, no problem.
Yeah, I would say that like it is a bit more expensive than a traditional insulation. So to justify the cost, I don't think I would put a concrete slab. Like I think you get this far, don't put a concrete slab on top of it.
Right,
I would put down like you're kind of.
Thinking about removing the insulate, the EPS, removing the foam.
Yeah.
And you could put,
Why not remove both the foam?
you put a sleeper and wood floor.
Yeah, right.
That's what I think. I mean, I think you could potentially. I think you could probably put in like a floating engineered hardwood on that. But the tamping is key. We had some settling in here, so we put that on pretty early in the project, and then we covered it in a product called Ramboard, which is like a recycled cardboard. And there were some dips and impressions that happened over time, and I think that had to do with not a good job tamping. So like there's tamping when you're in a form, and that's going to work really well. Doing it over a whole floor, it spreads out. So there's there's a technique that has to be developed there, for sure.
Could you not just subdivide the slab with some wood, especially if
Yeah.
you're using sleepers?
Oh yeah, you totally could. Yeah.
Contain
Yeah. That'd be awesome. Maybe you go around with a tamper. I don't know. We like again, like that's what I think is really cool about being a part of Endeavor is we try this, and like you learn through the failure. Well, not the failure, but you learn through the.
It's not a failure.
It's not a failure. Let's scratch
But
that.
you learn through the process.
But you learn through the things that come up. Things that come up.
Great question. So you put the pour over, right? So it was basically you dug down, and so you had undisturbed soil, and then you put the plastic on top, and then the pour over. So there was
No,
no.
this is on top of the existing concrete slab.
Is the existing concrete slab.
So
Existing
was it like a
concrete-
rat slab, or was it a proper slab with rocks underneath it for drainage?
No idea, they didn't bust it out.
No, there probably wasn't any gravel under it.
So let's say, could you do that? Could you just go?
Yeah.
Dig down to undisturbed soil, put plastic on top, and then pour over? Do you?
Yeah.
I would put a drainage
Yeah.
gravel layer and then plastic.
Yeah.
Yeah, that would
And
be better.
yeah, you want to,
You could also integrate a radon system into that. but
yeah, absolutely.
radon
Yeah.
mitigation.
And why the lime and not something else? Like what made you decide that?
I mean, I was taking that mix from Chris and his practice with it from the previous years, and I think that maybe just another line of defense and stabilizing it from.
Yeah, I think so.
I
I mean, they were pretty happy with just straight pour over and Medicaid that they did under the slab at 136.5 James, but they wanted
just another layer of,
yeah.
I
they
think.
wanted something a little stiffer, a little stronger.
So when it stabilizes, it's really like you can walk on it. It's not like different on the floor versus the wall, right? When
Oh,
you
yeah.
apply things, right? But on the floor, it's okay. Like it's done. It's the chemical process is finished and it's super hard and nothing's gonna affect it.
Yeah.
Yeah, like that was like we worked on that. Like we maybe did this in late June, and we worked on like we didn't put the earthen floor on this until mid-September. So this was our working floor for.
Oh, I see. So, but you are putting an earthen floor on top of it.
Yeah.
That was where my question.
Sorry, as a finished floor, yeah, and I wouldn't do it as a finished floor.
Yeah, no, I think it's still a little too. I mean, you'd have to coat it with
There's-
a bunch
there's-
of something.
Yeah, and like they have other. I mean, go check out the Pour Over website. They supply us for a different range of products. Like they'll cast like a tub out of it. So there's ways to finish it. I don't know the full composition of that, but I think there is some research to be done there.
It's soft as well. It's not as durable as an earthen floor.
Yeah, that's what.
So if you park a loaded wheelbarrow on it, it would take you.
Yeah. Yep.
Sorry.
Yeah. No. It's true. Well, it's a strange thing because it is. I mean, I know some people tried using perlite, and
I root for like.
okay, yeah, and it's harder than perlite. Like perlite can squish. Like it hits the saturation point, it starts to squish. The glass balls will never squish. So, but you could gouge, but yeah, but we protected it and we didn't have any gouges.
Wouldn't the perlite have higher insulation value than the glass?
I don't think so.
It's about R2 an inch.
Yeah.
Not glass. Oh,
Right.
like Rice Krispies.
Yes.
Yeah, well, I'd say perlite's like Rice Krispies.
Okay.
Yeah. That's what I'm
Yeah.
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 Looks the same.
Anyway, and
We should keep.
yeah, and
Technically, we're supposed to be anyway. Go ahead.
okay. No pressure. I just thought this was an interesting spot in the project. So we had, the students. We did remove the tar and gravel roof, which actually wasn't adhered that well, which saved me from more complaining, and and I just thought the light was really beautiful. Yeah, and you can kind of see the whole assembly coming together and kind of the guts of the project that the building nerds find really interesting, and a lot of other people don't. But we're about to do the hempcrete on our east wall. We framed in another section of wall over here, so we have a few areas that have two insulations. So this would actually have all cellulose. Here you have the pour over and cellulose. Here you have pour over and hempcrete. We don't do all these different insulations for any other reason than experimenting and teaching. So don't take away of like, oh, I got to do a whole bunch of things. Like we just like to play around with our students, give them exposure to stuff, and it's a process of kind of playing around and seeing what works. So here's a shot of us getting ready to install the hempcrete in our wall. Tim was talking about a really cool clip idea. Our students were excited on our on our windowsills. These are like kind of like the rough windowsills to cut out the top of the sill to be able to tamp your hempcrete. Also, you need to use BX wire in your hempcrete walls. So for anyone wanting to do hempcrete, make sure you got some BX in there. Hempcrete. Hempcrete with performance tapes, wool insulation. Deeper detail, but if you want to see that one again, there you go. So there's, performance tapes, everything happening at once. We tried using a Prosecco product. We didn't really love it. Here's a student blowing in cellulose. Here's what happens when your tape budget runs out and you try to use blue tuck tape. And as a review, it sucks. Don't do it. Here it is again. Here we are with the earthen floor. And getting into some more finishes. Tadillac in the bathroom. We did the whole bathroom in Tadillac. This was the EPDM on the roof. We got to reuse as a siding material. So underneath all these wood slats on the front, we were able to reuse all that rubber. Here's the inside getting finished up. You can see the window here. That's the fir beam. All the window jamb there. Some more Tadillac. There's so we got finished plaster wall, earthen floor, reclaimed sills, and then so this is the end. So again, not the most beautiful project in the world, but it was a 100-year-old concrete block, single-story building, and then yeah, there you go, beautiful.
Yeah, so we'll just have to.
What's that?
Corner chain
Thanks.
down there, and we're doing the raffle thing if you want to.
Hey, I missed the beginning of that. Where was it? Where was it?
That's in Peterborough.
Cool.
Yep.
And how long did it take you?
4 months.
4 months.
Yep.